Slide 1, Start. In the relentless pursuit of knowledge, scientists have pushed the boundaries of what's possible, shattering records and redefining our understanding of the universe. Welcome to a journey through the most extraordinary record-breaking experiments in scientific history. Imagine a place colder than the depths of space. In 2003, MIT scientists achieved the lowest temperature ever recorded, 0.45 nanokelvin. That's nearly absolute zero, where atomic motion almost completely stops. But why does this matter? This achievement isn't just about breaking records, it's about understanding the fundamental behavior of matter. On the opposite end of the spectrum, CERN's Large Hadron Collider created temperatures of 5.5 trillion degrees Celsius hotter than the core of our sun. For a fraction of a second, scientists recreated conditions similar to those just after the Big Bang. The LHC holds another remarkable record. It's accelerated particles to 99.9999999% the speed of light, creating collisions with energies of 13 tera-electronvolts. Each collision is a window into the fundamental structure of our universe. In 2020, chemists at the University of Manchester synthesized the largest ever molecular knot, consisting of 324 atoms linked in a complex pattern. This breakthrough isn't just about size. It's about understanding how we can manipulate matter at the molecular level. Speaking of chemistry, researchers at the University of Ottawa recorded the fastest chemical reaction, a molecular interaction that takes just 247 zeptosecons. That's a trillionth of a billionth of a second. But not all record-breaking experiments are about speed. The longest-running laboratory experiment began in 1927 at the University of Queensland, the pitch drop experiment. It demonstrates the flow of an apparently solid material over decades. In the realm of biology, the Human Genome Project set records for the most extensive DNA sequencing effort. But that's been surpassed by the Earth Biogenome Project, aiming to sequence every known species on Earth. These achievements have revolutionized medicine, leading to breakthroughs in genetic therapy and personalized medicine. The ability to read and understand DNA at this scale has opened doors we never knew existed. Looking to the future, scientists are preparing to break even more records. The upcoming Square Kilometre Array telescope will process more data per second than the entire world's internet traffic. Quantum computers are racing to achieve quantum supremacy with ever-increasing qubit counts. Each new record brings us closer to solving problems that classical computers can't touch. The next generation of particle accelerators promises to probe even deeper into the fabric of reality. The proposed future circular collider would dwarf the LHC, potentially revealing entirely new particles and forces. These record-breaking experiments remind us that science is not just about understanding what is, it's about pushing the boundaries of what's possible. Each record broken is a testament to human ingenuity and our insatiable curiosity. As we conclude, remember that today's records are tomorrow's starting points. Who knows? Perhaps you'll be the one to break the next scientific record. Keep questioning, keep exploring, and never stop pushing the boundaries of what's possible.